We are now going to use these rational exponents on numbers so that we can evaluate them. For instance, suppose we have 8 to the 2/3 power. Well, there's a couple of ways we could do this. We could turn this into 8 squared to the 1/3 and get the cube root of 64, which is 4. Or my preferred method is to do the cube root of 8, which is 2, and square that to get 4. So I like this method because it makes the numbers smaller first rather than making them bigger first. So we make them smaller and then make them bigger. So deal with the radical first and then come back and do the power. Okay, so let's look at another one. I'm only going to do this blue route from now on. If we start with minus 36 to the 3/2 power, we start with converting it to minus 36 to the 1/2 cubed. Notice that the power isn't seen by the negative sign, or the net power doesn't see the negative sign, rather. So this becomes minus 6 cubed, and 6 cubed is 216, so minus 6 cubed is minus 216. And there's our answer. Well, it's possible that we might get something like minus 16 to the minus 1/2 power. Now this is the same as, let's get rid of this negative exponent first, that's where I always start. 1 over minus 16 to the 1/2. The square root of minus 16 is not real, so that means that in actuality this is not a real number. We can't do anything with it. We can't take it any smaller than that. Okay? Well, what about 100 to the minus 3/2? Same thing. Let's do this as 1 over 100 to the 3/2 power. 1 over 100 to the 1/2 cubed. The square root of 100 is 10. Remember, 1/2 is the same. And 10 cubed is 1,000. So 100 to the minus 3/2 becomes 1 over 1,000. And the last one that I'm going to look at is minus 8 to the 2/3. Well, this is the same thing as minus 8 to the 1/3 squared. Minus 8 to the 1/3 is the same thing as a cube root of minus 8, which is minus 2. But when I square that, minus 2 times minus 2 is positive 4. And in this case, because it's a cube root, it's okay to be negative, but the square still makes it positive at the end of the problem. So again, always make your numbers smaller before you make them bigger.